damage. And so it actually binds to LDL particles on the ApoB protein. So ApoB is a protein that is on these lipoproteins. And it's a very important protein because that is what's used by the LDL receptors present on our liver to recycle LDL particles. And so what happens is these LPS particles are now bound to our lipoproteins, and our lipoproteins are still doing their function, right? They're going around and they're giving triglycerides and fatty acids and to some degree cholesterol to our cells that need it, right? We're constantly making new cells and repairing, and our cells need that. As they donate triglycerides and fatty acids, they get smaller in size. The lipoproteins, you probably heard of small, dense LDL, right? Like that's a very dangerous type of LDL particle. And that's one that's kind of been donating along, getting rid of triglycerides and whatever. If you think about a train with cargo, it's donating, dropping off the cargo. And so when it's time to get recycled back into the liver, what do you know? The ApoB protein's obscured by that LPS, and it's not recycled. And so it gets lodged into the arterial wall. And because there's an LPS bound to this, small, dense LDL particle, macrophages, which are, as you mentioned, it's like the first line of defense against something like a bacterial invader, right? It comes and chews it up, right? Gets rid of the problem. So macrophages come in because they're seeing this signal of LPS and think it's a foreign invader when it's actually just a small, dense LDL particle bound to LPS that came from the gut. Tries to engulf it, but it can't because it's not bacteria. And you get the macrophage stuck to that lipoprotein LPS, complex, and you get the formation of a foam cell. You've probably heard of a foam cell. It's the beginning of atherosclerosis. And so this is where gut health and the food we eat is it's linked to cardiovascular health.